How's it going? My name is Jonathan, and today we're going to go over the beginner's fundamentals for object-oriented programming using Python. So in this video, we're going to make a class. We're going to create the constructor for that class, and then we're going to instantiate the class, and we're going to also have a few methods and access those methods and members, and I'll show you how to do all that right now. So let's get right into it. So this is the class definition here. We'll comment this so that we can refer back to it later. So lowercase c class, uppercase D dog. So that's the name of our class. Well, now we're going to create the constructor. This method is called when a new object is created. So the constructor constructs the object. And to create this constructor, we're going to define double underscore init double underscore self. And then we have to ask ourselves, what inputs do we want to require when this object is made? So let's think, well, we can name our dog and we can give it a breed. Breed. Okay, so when the dog constructor is called, it's going to require name and breed. So now we have to set those members. So self.name, which is going to take this name variable and assign it there, and then self.breed equals breed. So there's our constructor. Now we can add methods to this object and then call those methods. So let's create the bark method. So just for good housekeeping, I'm going to write this out. This is an instance method which can be called on an object, and we're going to define it as bark self and print woof woof my name. Yeah, let's go. Just woof woof. Create another instance method. Here's another instance method. We're going to define that one as well. Get underscore info self automatically populates that. So this is why I love PyCharm, is that it does a lot of the work for you. And so when we call this get info method, we're going to have it print two things: name self.name, and then we're going to print breed. Oops, that's why that didn't come up right. Self.breed. So here we can create a new object of the dog class. So we're now outside of this class. We're not working within that anymore and defining members and methods. Dog1 equals dog. So we call this dog class dog, and we're going to pass into it Fido. And what is the breed? That's the second part we need, is golden retriever. And then we're going to dog1.bark. And so we're going to call this method, call the bark method on the dog1 object. And then we can also call dog1.getInfo. And what we're doing here is printing the info of the dog1 object. And let's run that. So name Fido. So it's only run this two method. Bark, which is woof woof. And then this is get info. Maybe we can just do this to clean up a little bit. print the get, yeah, so just to kind of show a little space there. So that's it. That's the very basics of creating a class, constructing the class, creating the constructor, creating members, storing variables, and that is the foundation of object-oriented programming in Python. If you get anything out of this video, please subscribe. I make content like this all the time. And thank you very much. Have a great day. Bye-bye. Hey, Jonathan here. Welcome to my part 2 of my series on basic object-oriented Python programming. In the previous video, we created the dog class, and we created the constructor and defined some methods and members of that class. And now we're going to go over inheritance. So inheritance is a principle of object-oriented programming, and we're going to create a new class that inherits from the dog class. So here we create a new class that inherits from dog. And by the way, please subscribe. I forgot to ask for that in the other video, but please subscribe to my channel. I'm trying to get to 1,000 subs. So we're going to create a new class. Sorry, lowercase c class service dog, which inherits from dog. We're going to define a new constructor that accepts self, name, breed, and task. Okay. And we're going to use a new method here, or we call the parents classes constructor using the super method. So this is a new method that I haven't covered yet. So the super method calls the constructor of the parent, and this, the service dog is the child class. So so yeah, let's go over that example. So within this within our constructor, we're going to do super dot init name breed and self dot task equals task. So you might ask yourself, why are we only assigning this one? Because this super constructor is calling these here. So we only need to assign task here because name and breed have already been passed into the super constructor. And now we can define get info self. And we're going to call the parent object get info print task self.task. So this is going to print out 3 things actually. It's going to print out all these get info items and in addition to the task. And we don't want to have to recode this. We don't want to rewrite this. This is the whole principle of object-oriented programming, is that we don't have to redo the super's parent objects methods. We can just call super.getInfo. So let's look at this in action now. Dog1 equals service dog. Its name is going to be Fido. It's going to be a golden retriever, and its task is going to be guide dog. So we've created that object. Now we're going to dog1.get, get info. And let's see what that gives us. Its name's Fido. It's a golden retriever. It's a guide dog. And we can clean this up a bit. Task. Yeah. Okay. But you might notice too that in service dog we didn't redefine this method here of bark. Dog1.bark. So it has that method, even though we're not, we didn't assign it in the subclass that was inherited from dog. So that's kind of the beauty of object-oriented programming, is that you don't have to rewrite your code over and over again. You can do it one time, and it kind of is the most efficient way to program if you're going to be doing more complex tasks. That's a big if, though. So sometimes you're not doing complex tasks, and it's not super important to be object-oriented, but if you are, object-oriented is the way to go. So thank you so much for watching. Please check out the next part. I guess that'll be part 3, and subscribe and comment and like and give this video some attention so that I have more incentive to keep making these. Hey, how's it going? Jonathan here. In this tutorial, I'm going to give us an example of polymorphism in the context of the dog class, and this is part 3 of my series. So there's part 1 and 2 before if you want to see how we got here, but we're going to customize the code we have already, which is here, and add polymorphism to it. So what's step number 1 to modify this class so that it has polymorphism? Well, we're going to add a new method, and that method is going to be called make sound self, and pass into itself. And what we're going to do here is print woof. Okay, so that's the generic parent level make sound function. If you're a service dog, we will add another function, def make underscore sound self, and what that does is prints I'm working, because it's a service dog. And now we're going to make a third class, and that class, excuse me, is going to be called poodle, and it inherits dog. And to make it, we have to define the constructor. Oops, excuse me. Self, oops, name, breed, self name breed, and that calls the super dot init self name, and then move the keyboard over a little bit. There you go. Super init name breed. Yes, there you go. And we're going to define the make sound function. And what does the poodle do? Poodle goes yip. Yep. So now, depending on the type of object we create, it's going to be, it's going to have a different output, right? It's going to give us a different sound when we call that sound. It's going to be dependent upon the type of animal it is. So let's do dog underscore service equals dog, and then the name and breed, right? Name and breed is going to be Fido, and the breed is going to be Shepherd. Oops, no, this isn't the best way to do it. Let's do it a different way. Dogs equals, we'll make an array. Fido. And then we'll make a service dog, which is Buddy. And it's a guide dog. And then we're going to do a new poodle. I'm just going to be fluffy poodle. And then we'll do a for loop for dog in dogs, dog.make sound. So we'll go through each one and we'll call the make sound method in each one of them. Woof, I'm working, and yip yip. So we have the first dog here, which is just Fido, and Fido goes woof. The service dog goes, I'm working, and then the poodle says yip yip. Easy enough, huh? See, this was made defined here. Woof. I'm working, and yip yip. And that's an example of polymorphism. If you get anything out of this video, please hit the subscribe button. Thanks. Then here, and today we're going to talk about overriding in the context of object-oriented programming and how it's implemented with Python. So before we get into the code, I'm going to go over a quick overview of what is object-oriented, or what is overriding. So in object-oriented programming, OOP, overriding refers to the ability of a subclass to provide a different implementation of a method that is already provided by its superclass. When a method in a subclass has the same name, return type, and parameters as a method in its superclass, it is said to override the superclass. When a subclass overrides a method, it can provide its own implementation of that method, which may differ from the implementation in the superclass. This allows for the subclass to inherit the behavior of the superclass, while also modifying or extending that behavior to suit its specific needs. It is important to note that when a subclass overrides a method, the subclass's implementation of the method will be called instead of the superclass's implementation when that method is called on an object of the subclass. Okay, that was long, wordy, but now let's talk about let's actually implement that. Okay, so here's the example. I'm going to call this class parent, and we're going to define a method called display. And what that's going to do is just print out, this is the display method of the parent class. We'll create another class child, just child, and it accepts parent. And we're going to define display, which is the same method name, now being defined by the subclass. Print, this is the display method of the child class. P equals parent. P dot what? P dot display. And this is going to output the display method of the parent class. C equals child. C dot display. And this is going to output the display method of child class. Okay, so we should have 2 lines of code here. There it is. This is the display method of the child class. Let's clear this out again. And yeah, this is the display method of the parent class. This is the display method of the child class. So we're just overriding the already existing method in the parent class. And we're doing that from the child class. What if I said this? Just change the name, add a Z there, just to goof it up. Now they both do the same. Now they do this. So we've overridden that method. So that's it, pretty basic. Don't overthink it. Easy peasy. And thanks for watching, and have a great day. Oh yeah, by the way, sorry. Please hit the subscribe button if you like these sorts of tutorials. Bye-bye.